These are the solutions to the 2017 Graphs and Relations SAC. So without further ado, let's get stuck into them. So here's question 1. And what we've got is a sustainability program at the college, and we've got this 12,000 litre tank which collected rainwater on the roof of the Helen Tui building to water the garden. And so at the end of the summer there was only 10,000 litres left in this tank. So this was a pretty important piece of information here. Over a 4-day period it rained at a steady rate and the volume of water in the tank increased to 9,000 litres. Alright, so what they want to do is sketch the graph V versus D. So this is V for volume and D for the amount of days. And when it first started raining, or at time 0, it had 1,000 litres left in the tank. So this was your first point here. Okay. And then when it finished raining over the 4-day period, so this is the first day, second day, third day and fourth day, there was 9,000 litres left in the tank. Okay, and then what you have to do is draw a straight line connecting them. Where's my ruler gone? I'm going to pause this. Okay, evidently my son had stolen my ruler. So anyway, here it goes. Now, it is a little tricky to draw straight lines with a stylus, so you're going to have to excuse me a bit here as I try and draw a straight line. Okay, here it goes. That didn't work, did it? Let's try again. Okay, so straight line connecting the two. Okay, now your endpoints had to be marked with solid fill. Okay, and you weren't allowed to have an arrow on the end of that indicating that it continues, because you were supposed to do it over these values of D between 0 and 4 inclusive. Okay, so the 3 marks there came from one for the endpoint, another one for the endpoint, and one for the labelling of the axes. Okay, now what does the Y-Intercept represent in the context of this situation? Well, this is 0, 1000, that's the Y-Intercept. And you need to say something about at the beginning or the initial, okay? So it represents amount of water in tank when rain started. Okay, so the key was started. You needed, the other words that I was looking for were initial or beginning before the 4-day period of rain started. Okay, the gradient. Okay, so what you needed to do was use the 2 coordinate points, which were 0, 1000 and 4, 9000, and whatever method you used, that you didn't even have to show working out, although many of you did. You would have found that the M equals 2000, and then you had to explain what it represents, and you needed something like for every increase of 1 day there was another 2,000 litres of water added to the tank. Okay, so you needed to say something explicit like that. Okay, state the equation and appropriate domain for the volume of water in V litres in this tank while it's raining. So would have been V equals 2000 D plus 1000, so that's the gradient and the Y-intercept. You needed these 2 variables here, so not X and Y but V and D. And you also needed a domain statement. A lot of you struggled with that. You either didn't include it or included the range, but it was actually just in the question before, so it was 0 less than D less than and equal to 4. That was the domain. They're the number of days that were appropriate. Okay, so on to this question here. A lot of you did quite well on this one. Okay, so we've got the Colester College bus, and we're measuring the engine speed in RPM over a period of 30 seconds. Alright, so at 3 seconds, which is roughly here, okay, we're saying it's about 2000 RPM. And at 25 seconds, which is there, okay, that's where we are there, so there's 2200, 400, roughly 2600 RPM at that point in time. 23 seconds, oops, 25 seconds rather. Yeah, so roughly 2600 RPM. Find the total time the engine speed was over 2200 RPM to the nearest second. So here's 2200, which is between there and there, which is 2 seconds, plus between there and there, which is between 20 and 28. Okay, so that's, let's see, 2200. So yeah, so between 2 and 9 seconds. Let's see if I've got this right. 4 and 8. Sorry, 4 and 8. Okay, so here's 4 seconds between here and here, and here is 8 seconds between here and here. So 4 plus 8 equals 12 seconds. Okay, the approximate maximum engine speed, answer to the nearest thousand, and what time did it occur, answer to nearest second. So here is where the engine speed gets to its highest amount here, so it was at 23 seconds, and to the nearest thousand would be the middle of 28 and 3000, which is 2900. Okay, so the answer needed to be specifically 23 seconds and 2900 RPM. Okay, half each for those. At what rate does the engine speed change between the 8th and the 10th second? Okay, so here's the 8th and here's the 10th second. Okay, and what we've got here is 1200, 1400 is this value here, and this value here is 2200. Okay, so what many of you did was just subtracted the values and said it was 800. That's the change, but actually it's at what rate? Okay, so between the 8th and the 10th second. So at the 8th second it was going 2200, and the 10th it was 1400. Okay, so what you need to do to work out the rate that it changes, you need to calculate the gradient. So you would have found that using those two values, m equals -400, and you needed to have another statement in there interpreting that, okay, which is decreases by 400 RPM every second. Okay, so that needed to be in there, that word decreases. Okay, so Ms. Gabriel wrote a book called My Trip to Africa, which would have been obviously quite riveting reading. She is considering 2 possible contracts for the sale of her book. This is the graph for Ms. Gabriel's earnings, E for contract B if N books are sold. Okay, so clearly we can see that for the first part here, we've got a steady gradient between 0 and 200 books, and then what happens is the gradient increases from here on. So obviously if she sells over 200 books, she's going to get a better return. Alright, so the first thing you had to do was calculate these A, B, C and D values. Okay, so they will show that question, so you had to show that the value of A was 2. Now a lot of you, what you did was just choose points and sub them in. That's not good enough for a show that question. That just shows that a particular point is on a line. Okay, so the way you show that the A value for this is you calculate the gradient. So what you need to do is use coordinate points, which was 0, 0 and 200 and 400, and show that y2 minus y1 equals, so you would have found that m equals 2. So you needed to do 400 take 0 over 200 take 0 equals 400 over 200 equals 2, okay, to show that that was the value. Now you would have had to do the same thing for this. You would have used the point 200, 400, and this one here, which was 400 and 1100, and again after doing y2 minus y1 you would have found that m equals 3.5. Okay, so I'm not going to do it for you in the solutions, but you needed to have y2 minus y1 there. Alright, so for this one here, to get the c value, which was the constant of this one here, once you've found the b value here, you would know that the graph would be y equals 3.5x plus c, and you would have subbed in, or you needed to sub in a point which was, say, 400 equals 3.5 times 200 plus c, and once you transposed it all, c would have equaled 300. So that was good enough for a show that. Alright, this one here wasn't a show that, you just needed to state the value of d. Okay, and you can see here that d is the values of which this equation is true for. It's between 0 and d, okay, and for what this equation is true for, it's greater than d. So actually that must be this value here. Okay, so d would have been 200. Okay, a lot of people said 800 on that, but it's 200. Okay, the sale of Ms. Gabriel's book using contract A can be represented with this rule here. So state the gradient of the rule and explain what it means in this real life situation. Okay, so what that means is for every book sold she would earn $2.50. So M equals 2.5, and therefore Ms. Gabriel would earn $2.50 for every book sold. Okay, so now what you have to do is sketch the rule for contract B between 0 and 800. Okay, so what we can see here is there's no Y-intercept, or there is one, it's at the origin. And what we're going to do is, because we're told to sketch it between 0 and 800, we're going to use the endpoints. So we're going to work out what E will be, how much she would earn if she sold 800 books. So let's jump on the calc for the first time in the SAC. So we've got 2.5 per book. We're going to multiply that by 800, and it says that it's 2,000, which conveniently on our Cartesian plane is up here. Okay, so then what you had to do was rule a line between these 2 points. Again, I'm going to try it, so excuse me while I fumble around a bit with this. Okay, not the best line there, okay, but that'll just do for the moment. Okay, and there's our graph. So it would have been 1 mark each for, or half a mark each for endpoints on that. How much was it worth? 2 marks, so 1 mark each for endpoints. Deducted marks, a lot of you guys put an arrow on there to say it continues, but this says to sketch it over this domain here, which means it's only true between 0 and 800. So yeah, you needed to mark the endpoints on that. So how many books will Ms. Gabriel need to sell so that her earnings using contract B are greater than her earnings using contract A? So there's a couple of ways of doing this. Most of you, I think, just read it off the graph, and you knew that this point here, the break-even point, was the point where both of them are the same. Okay, so many students said 300 books here, but that's in fact not quite right. Okay, it actually needs to be greater than 300 books. Okay, 300 exactly will mean that the earnings are exactly the same, and the question says earnings for contract B are greater than earnings for contract A, so it needed to be greater than 300 books. You could have done it also using not financial solver, I'm still thinking of recursion here. You could have done it using simultaneous equations, so y equals 2.5x, and the other equation which it intersects is this one here, which is y equals 3.5x, what was the y-intercept? Take 300. And once you did that, it would have said that x equals 300 and y equals a value that doesn't matter, and that was the value that you needed to interpret there to answer that one. Okay. Alright, on to this, the souvenirs question. Okay, so she purchased so many souvenirs whilst in Africa, which you'd understand, that she couldn't fit them in her baggage, so she decided to basically dump them, okay, get them back to Australia so that she can move on to her next place. So she visited this local post office in Rwanda, who listed the cost for mailing packages depending on the weight as this, okay. So the cost to send a package more than 2.5 kilos, but no more than 5 is 7. So you just need to continue the pattern here. It would have been 2.5 less than W less than or equal to 5 is $7. Most students got that one right. Okay, so then down to the step graph here. Okay, so I'm not going to do the whole thing for you. Most of you got this right. Between 0 and 1 was $3.50. So we need to find 350, which is, this is $3 here, this is 350 here. Now it had to be between 0. So we're going to open circle that, close circle on 1, and line connecting them. Okay, and then the next one, I'll just do the next one as well. 1 to 2.5 was $5. So there's 1. There's $5 here. It needed to be open circle, and 1 to, what was it? 1 to 2.5. So here is 2.5 here, was closed circle and connected. Okay, so it needed to follow the pattern of open circle, closed circle, and line connecting them. Some of you joined it up with a dotted line down there. That was cool. Any mistakes on that? I actually used the overhead transparency of the correct solution and overlaid it onto your solution. So I'm very confident that I've marked this one correctly. And yeah, basically anything was out. I think I marked you half a mark off for each time you messed up this, and half a mark off for not getting the endpoints correct. That is the open and closed circles. Alright, so how much would Ms. Gabriel have been charged to send a package of souvenirs that weighs half a kilogram? Okay, so this is weight in kilograms. Half a kilogram, there's 1. There's half a kilogram. It would have been $3.50. Alright, she opens her wallet and finds that she has $10. What's the maximum weight of the package she can spend? So this one, I think from memory, was 8 kg, $10. Max weight was endpoint of this part of the domain here, okay, which was 8 kilos. So she can send one for 8 kilograms. Alright, so she thinks that that might be a bit dear in Rwanda, so what she does, she waits until she's in Tanzania to send them home, and it runs according to this hybrid function. Okay, so what we can see here is this is a classic step graph, and this one here, now this one tripped up many students. Alright, so what I'm going to do is, let's draw the step graph. So it was 350, so here's $1, $2, $3, 350 is here, between 0 and 1, so we're going to open circle, close circle, line, and $5 between 1 and 4, open, close, and line. And it's this one here that many of you had trouble with. Okay, so what we're going to do is sub the endpoints 4 and 10 into this. Alright, so we've got 2.5, so we're looking for the value of cost, or what cost is 2.5 times 4. That's $10. So we're going to open circle that. and then we're going to find it out when W is 10. So 2.5 times 10 is $25, which is up here, and we're going to close circle this. Okay. Hang on, that's not right. That's the weight 10, 25 here. It should be. Sorry, my mistake. Okay, so there. Again, I'm just trying to draw this with a stylus. Ooh, that's no good. The reason I struggle with this is because I can't actually see where I've put those 2 points down on my pad that I've got here. So I'm just going, yeah, alright, that's going to have to be the best we do on that one. So yeah, heaps of students didn't get this line here. That was a real struggle. The funny thing was, many of you couldn't graph it, but you could apply it. Okay, so show that it will cost $18.50 to send a package that's 500 grams, which is 0.5 kg, and 6 kilograms in Tanzania. Okay, so according to the graph, there 500 grams fits into this slot here, which was $3.50, plus 6 kilos is in this range here. So 6 kilos would be $15, okay, but we're going to show that, so we're just going to say that it is $2.50 times 6, which is $18.50. So that was good enough for the show that. Alright, so we're comparing 9 kilos or more than 9 kilos from Rwanda and Tanzania. So what we're going to do is sub 9 exactly into both of them, and then compare the amounts. Okay, so 9 into Rwanda would have been $14. So you just needed to identify that. So Rwanda, $14, and Tanzania would have been 9 times 2.5, I think. 9 2s are 18. Rather than do that in my head, I'll jump over here. 9 times 2.5 equals $22.50. And obviously then there's a price difference there of $8.50 cheaper in Rwanda. Okay, so whilst we were studying hard in back in Melbourne through that freezing summer, although they did say it was the hottest on record, but I don't know, felt pretty cold to me. Ms. Gabriel was over walking with these lines, okay, and she had a touring party of 7 people. Owners of the business pay a guide $100 for the afternoon and $5 per person for insurance. So state the rule for the cost. So cost is $5 per person, so 5N plus the flat fee that the guide gets. How much will it cost to run the activity that afternoon if all members participate? So C equals 5 times 7 plus 100. C equals 135, so $135, which is pretty cheap. I dare say you pay a bit more than that. Each ticket for the activity is sold at $29. The revenue rule, so got all sorts of crazy things on this one, but the reality is it's just $29 per person, 29N. So if 12 tickets are sold that afternoon, what would be the profit? Well, profit equals revenue less costs. So profit equals, so we could work out revenue on 12 tickets. So we go 29 times 12, which was 348. Subtract, a lot of you subtracted this 135, assuming it was 7 people, okay? But 12 tickets were sold that afternoon, so you needed to sub 12 into the cost function. So it was 5 times 12 plus 100. What don't you like about that? 160. And what you would have found was that the profit, that looks like an R, profit equals 188, so $188. What's the minimum number of tickets the owners need to sell in one afternoon to make a profit? Okay, so hang on a sec, I'm just going to pause this. Okay, so what we're looking for to answer this one is the to make a profit. What we're going to do is calculate the break even. So we know that C equals 5n plus what was it, 100, and R equals 29n. So what we're going to do is solve that simultaneously. Okay, so we're going to go menu, algebra, and we're going to go system of linear. Alright, so instead of C and N, we're going to use Y equals 5x plus 100, and also Y equals 29x. And we're going to control enter on that to get an approximation. So it's saying we need to sell 4.16. Okay, so N, the number of tickets, is 4.16. Okay, so what that means is we can't sell 0.16 of a ticket. So we can't also round it to 4 tickets because 4 tickets won't be enough to make a profit. So actually the answer is therefore 5 tickets must be sold to make a profit. Alright, determine the number of tickets that are sold if the owners make a loss of 28 bucks. So this is negative 28 is kind of like the profit equals 29 n take away 5n plus 100, and what you would do is throw that into solve on the calculator and it will say n equals, so let's go and solve negative 28 equals 29x take brackets 5x plus 100, brackets are really important there, comma x, and n equals 3, therefore 3 tickets would have been sold. Alright, now on to the non-linear. Okay, so she commenced the day of the walk with lines with 200 ml of water in her drink bottle. It was a hot day and she frequently sipped small amounts of water from her bottle, and this shows the volume of water that Ms. Gabriel had drunk after tea hours. So what we're assuming is that it's going to go up like this, because as time increases, the volume of water consumed is going to increase as well. Okay, so what we want to do is plot V versus T squared here. So first of all we're going to work out T squared. So 4, 16 and 25, and then we're going to plot these points. So 4, 300. So that's here, and 16, 1200. That's there, and 25, 1875. So there's 18 somewhere up here. And what you'll note that it is a straight line. So some of you, if you plotted the points, that was fine. If you drew the line, that was fine. I accepted either. Okay, so what we want is the rule. Okay, so it's going to go through the origin and run through these points here. So one of the coordinate points will be 0, 0, and you can choose whichever other coordinate point you want. So let's go 4, 300. And work out the gradient, and you would have found that m equals 75. So the rule is going to be y equals 75x squared, and let's switch the variables around. So volume of water equals 75 t squared. Alright, how long did it take to drink all the water? Well, that would mean that she drank 2000 ml, 75 t squared, and t equals, run this through your calculator on solve, 2000 equals 75x squared, and we want to solve for x, control enter, And we're looking for the positive solution, which is 5.16. We want this to 1 decimal place, so 5.2 hours. Alright, so on to the linear programming questions, and these were done overall really, really well. Okay, so became friends with a woman who runs a business called Souvenirs Question. They manufacture wooden giraffes and wooden elephants, and she's been asked to help her friend maximise the number of wooden giraffes and elephants that can be manufactured, because she's got this just expertise in linear programming. So isn't she a great friend to have? Souvenirs are cut with 2 saws, saw A and saw B, and they operate for a maximum of 8 hours per day. So these are the constraints. So these are how saw 1 operates. It takes 1 hour to cut out a wooden giraffe and 30 minutes to cut out a wooden elephant. And saw B takes 40 minutes to cut out a wooden giraffe and 1 hour to cut out a wooden elephant. So X is giraffes, Y is elephants. These are the constraints. And saw A's constraint is this, and this is saw B's constraint. You need to show why it's this, because really these numbers aren't anywhere here. So a lot of you had trouble working this out, and it's got to do with the time. Alright? So if it's 40 minutes to do a giraffe and an hour or 60 minutes to do an elephant, that must be less than 8 hours, okay? Where 8 hours is 8 sixes, 6 eights are 480 minutes. So we've got minutes, minutes, minutes. Alright, now what we're going to do is divide by 10, 4x plus 6y less than 48, and let's halve these, 2x plus 3y less than 24. Whoops, that shouldn't be less than or equal to. Okay. Oh no, it should be. Yep, it should. Sorry, my bad. Alright. Okay, so that was the show that question. Alright, so now you had to graph it. Okay, so let's write them down. X greater than or equal to 0, Y greater than or equal to 0, 2x, forgot them already, plus 3y less than or equal to 24, and 2x plus y less than or equal to 16. Okay, so first of all let's graph x greater than or equal to 0. That's this one along here. So again, you need to use a straight edge for this, but I'm not going to do it. X greater than equal to 0. And those of you who couldn't figure out that this is a quadrant 1 graph, of course it has to be, because we're manufacturing stuff. And you can't manufacture negative amounts of something. And this one was, what's this one? Y greater than or equal to 0. Okay, so now let's do this one here. So we're just going to grab the x and the y-intercepts. So I like using my inters program. Whatever way you get your intercepts, that's fine. So 2x plus 3y equals 24. Says the x-intercept is 12 there, and the y-intercept is 8, which is there. Alright, I'm going to attempt to draw a straight line. In fact, I'm going to pause it while I do it. Okay, so there's my straight line. You can see I've had a few goes at it, but anyway, there it is. Now, we're going to just quickly use the test point on this. So sub in the origin, 0 less than or equal to 24, that is true, so that means that we're going to blot out this side. This is, again, quite typical for a manufacturing product. Is what we do is we start limiting these infinite amount of things that we can manufacture. Okay, so what we do is we narrow it down to a feasible region enclosed here, because it says that basically we've got a finite amount of things we can manufacture. Okay, alright, so now we're going to graph, let's label it actually, so that is 2x plus 3y less than or equal to 24. And again, let's use, or go over to the calculator, and chuck in the next function, which was 2x plus y equals 16. Oh, what did I do? 6y. No, 2x plus y. What am I doing? 8 and 16. There's 8. So x equals 8, y equals 16. There they are there. Again, I'm going to pause. Okay, so there it is drawn. And again, I just know these functions here limit the infinite possibilities. So I know that this side is going to be blotted out. But let's quickly use test point. 0 is less than or equal to 16, which is true, which means this side is true, this side is false. Alright, so let's put a key in, which is region required. And that's all you had to do there. Okay, so justify whether it's possible to manufacture 2 wooden giraffes and 7 wooden elephants given the constraints. So here's 2 and here's 7. Okay, so what a lot of you said was no, outside the feasible region, which is true, but you really needed to justify it, and for 2 marks that just wasn't going to cut it. Okay, so what you needed to do was sub it into this one here. Okay, so what this line here, 2x plus 3y less than or equal to 24, you needed to sub it in there, 2x plus 3y less than or equal to 24. And what we're going to do is put the 2 wooden giraffes and the 7 wooden elephants. So 2 times 2 plus 3 times 7 less than or equal to 24. 4 plus 21 less than or equal to 24. 25 less than or equal to 24. Therefore, does not satisfy constraint. Okay, so that's what you needed to get the full marks on that one, and not many students did. So here is the objective function, so you needed to graph it, using dotted line or whatever. Alright, so the z equals x plus y one is the one that has the same x and y intercept values. Okay, so 1 and 1, 2 and 2, 3 and 3, etc, etc. Okay, so I'll grab my different colour, blue, and you could have gone for whatever you want. A lot of you, for some reason, went for 5 and 5 and then just ran it through there. You needed to rule that up. Okay, that was fine for that. Calculate the maximum number of souvenirs that could be manufactured in a day. Okay, so to do that one, you just needed to grab the corner points, which would be 0, 8. So this one here, A, this one here, which we don't know yet, this one here, which is 8, 0. The origin, and the intercept of 2x plus 3y less than 24, and the other one. So what we're going to do, we'll just jump on linsolve and get it. A lot of you didn't because you could see it pretty clearly off your graphs. Algebra, system. So we've got 2x plus 3y equals 24, and 2x plus y equals, what was it, 16, and it was 6, 4. Okay, then what you would have found, you would have subbed in each of them to get a value. The maximum number of souvenirs manufactured is 0 plus 8, which is 8 in this case, 8 in this case, none in this case. Of course that's not going to be it. Or this one here, which was 10. So it was max 10 souvenirs a day. So in order to cover costs, Souvenirs R Us will need to manufacture and sell more than 4 wooden giraffes and more than 3 wooden elephants. So more than means the next possible value would be 5 and 4. So what you needed to do was just check whether that was a possibility, which was 5 of these and 4 of them. There it is there, definite possibility. So it would have been 5 and 4, which were 9 in total. Okay, not many students got that one right. Okay, so last question here. Souvenirs are us getting ready to load up souvenirs to deliver to stores. They can be delivered in small crates or these large crates. X is small, Y is large, and we've got these constraints here. And so what they mean, so 0 or more large crates can be used, and 4 or more small crates must be used. And I'm just going to get rid of that word can and say the word must. Alright, so space limitations on the truck mean that no more than 24 crates can be transported in a single order. Okay, so write down the third constraint. That is the classic x plus y is less than 24. Okay, so the number of small and large crates added together has to be less than or equal to 24. A small crate weighs 3 kilograms and a large crate weighs 24 kilos. A minimum weight limit of 120 kilos applies to each order to fulfill the truck hire policy. So basically they're saying, look, we're not going to carry less than 120 kilos worth of stuff. It's not worth it. So that is 3x plus 8y must be greater than or equal to 120. Okay, so a lot of students wrote less than 120 on that one here. So it has to be more than 120 kilos. Alright, so what this is the graphs of constraint 1, 2 and 3. So this is x equals 4, or the line x equals 4. The line y equals 0, and this is x plus y less than or equal to 24. And so what we're going to do is quickly shade up these ones here. So again, it's a quadrant 1 or a manufacturing situation. Okay, this one here is x plus y less than or equal to 24, so test point 0 is 0 less than or equal to 24. True, so this side is true, this side is false. See you later. And let's graph this last one, which was 3x plus 8y. So let's go to inters on the calculator. Oops, not that. 3x plus 8y equals 120. 40 and 15 are our x and y intercepts. There's 40. 15 is over here. Alright, I'm going to pause. Okay, so there's my line, and this is the line 3x plus 8y was it greater than 120. Alright, so because it was greater than 120, let's test point it at 0. 0 is not greater than or equal to 120, which means this side is getting knocked out, which means these are our corner points right here. Let's make it really clear. And alright, so corner points to 1 decimal place. So we're going to have one here that I'm not 100% sure about. This one I'm pretty confident is 4,20. What we're going to do is see where these intersect. So let's use linsolve. And we're checking the intersection of x equals 4 and what is it, 3x plus 8y equals 120, and 1 dp for 13.5. And let's go again. Intersection of this and x plus y equals 24. $14.4 and 9.6. Okay, if exactly 10 small crates are packed in the truck, what's the maximum number of large crates that can be packed in the truck? So 10 is the small, so what you need to do is go up, and what you would find on your graph there is that you could get 11. It doesn't look like it on mine, okay? But your graph, when drawn appropriately and going through 40, you'll find that it is 11 large is the maximum. Okay, so you need to use the graph to work that one out. Z is the profit, and small and large crates is 36 and 60. So this is just a bog standard objective function problem, 3x, 36x plus 60y. Find the maximum, so you need to sub each of those corner points in. So you need to work out 4, 20, and what was the other one? 4, 13.5, and 14.4, 9.6. Did I get them right? Okay, and if you did this, I've just got the solutions here next to me, so I'm not going to work them out, but if you're not too sure, do them on your calc. So for this one here, 1344, this one here was 414, 7, 10, 40, okay? And so therefore this is the winner, so 4 small and 20 large gives profit of that. Okay, so due to a truck shortage over the weekend, the number of crates that can be transported needs to be reduced. Now the maximum of large crates that can be delivered is 16, so graph the additional constraint, y less than or equal to 16. So here is 16 here, so what you need to do is run this across like so. A lot of you drew the line but didn't actually shade it, okay? So that means that it has to be less than 16, which knocks out this. So this also would then give us new corner points at these places here. Okay. Now, so we're going to have one corner point here. Hang on a sec. Okay, so we're looking for, we already know the values that we get out of these ones here. So what we're going to do is look at these new corner points here, which is 416, okay, and this one here is 816. If you're unsure of that, again, use linsolve on the calculator to work out that one if you want. But yeah, trust me on that, the 2 points are 416 and 816. They're the 2 points. So if you sub them into the objective function, this would give you $1,104, and this one would give you $1,248. Okay. Now I know that there's 2 other corner points there, but we've already found them earlier. That's these 2, and notice the values that they give us just much lower than these 2 here. So in fact, this is our next new condition that we would look at. So maximum profit would be 1,248 delivering 8 small and 16 large crates. And that's it. Alright, so don't hesitate to come and ask me any questions once you get your SACs back, and you know, make sure you clarify anything you want there.